All right, so in this video, we're going to talk about operations with complex numbers. And we're going to title this part 1 because we're not going to get to all of the operations in this video. First thing I need you to do is I need you to read John and Betty's journey through complex numbers that was linked to the outline. It does a really good job of explaining a little bit better than what I'm going to about what a complex number is and a little bit of background as to maybe where it comes from. And so if you have not watched it, hit pause, go back and read that, okay, and then you can continue on. But if you have read the little book, then let's start summarizing some of the key concepts, okay, from that little book. So the question that came up was, what number times itself equal to -1? And where Betty and John were puzzled was that when they multiplied 1 times 1, they got positive. And when they took -1 times -1, they also got a positive. So in a sense, what they did was they created this imaginary number I so that I times I equaled -1. And so what that means is that I squared is equal to -1. So when we simplify problems and we see an I squared, we're going to replace that with a -1 so that we can further simplify. Well, if we square root both sides, let's now talk about what I is equal to, and I is equal to the square root of -1. So before, when we had things like the square root of -4, we would just say not possible or no real solutions. But now what we can do is we could denote this as being the square root of -1 times the square root of 4, okay? And what we can do is we can now simplify it, and we can take the square root of 4 and say that it's 2, but the square root of -1 is now going to be denoted with the letter I. And so what the I does is it allows us to work with negatives underneath the radical, but it gives us an easier symbol to work with the I. Okay, we'll see more of that as we go. The second concept that they talked about was what it means to be a complex number. So the issue was kind of, well, what do you call it when you have, for instance, a real number and you combine it with an imaginary number? And so the 4 would be the real number part, and the 5i would be the imaginary part. So if you're going to combine a real number with an imaginary number, that's what's called a complex number. And complex numbers are always written as a plus bi, okay? Or it could be a minus bi. But we always kind of assume that when we write complex numbers that we write the real part first and then we write the imaginary part. So examples of complex numbers could be, for instance, it could even be like square root of 3 plus 2i. I think that's one of the big misconceptions, is that square roots are all imaginary, and that's not true. The square root of +3 is a real number. The square root of -3 is an imaginary number. So that would be an example. It could be something like this, where maybe it has all imaginary parts. But you could also call a number like this, like 7. You could also technically call it a complex number because it has 7 real parts and no imaginary parts, okay? So that's kind of what we mean when we call them complex numbers. All right, let's get to a few examples. First thing we're gonna do is let's practice simplifying imaginary numbers. So suppose we have the square root of -12, okay? Well, we're gonna split this, right? That we have the square root of -1, which is what makes the negative part. The square root of 12 can be split into the square root of 4 and the square root of 3. And so when we simplify this, the square root of -1 is denoted with an I, the square root of 4 is 2, and the square root of 3 cannot be simplified. So what we can do is we can write this as 2i square root of 3. And so really, simplifying the square root of -12 is exactly like simplifying it like we did. The only difference is the I denotes the negative. So we'll get a little bit more practice with simplifying, but let's go ahead and keep going to a few operations. Example 2, let's try a little bit of adding and subtracting. Suppose we do 7 minus 6i minus 3 minus 6i plus 2i, okay? Well, I, again, is just a symbol, very much the way that x is a symbol, and it's gonna work very similar in that we combine like terms. So when we have something like this, let's go ahead and take a step. This is like having a +1 in front, so if we distribute a +1 here, nothing's gonna change. And this is like having a -1 in front, so we're gonna have to -3 and then we're going to add 6i once we distribute that -1. Okay, and so what we can do is we can combine like terms, and we can add all of our real parts. 7 and -3 is going to make a real number 4. And then we can take all of our imaginary parts. We've got -6i plus 6i plus 2i. Well, -6i and positive 6i will cancel, and we have 4 plus 2i. And we're going to leave it just like this. Okay? So really, I think what you're going to find with adding and subtracting is it's very, very similar to working with an x. Now, where it's a little bit different is when we multiply. Okay? So first thing, I'm going to write down 3 minus the square root of -4 times 5 minus the square root of -36. So first thing when I look at this is it looks a little overly complicated by the fact that we have these radicals in it. So again, let's remember the convenience of using this imaginary number I is so that we can denote this square root of -4 as a 2i. And it gives us an easier way to work with negatives underneath a radical, okay? And then this is going to be 5 minus, but since 36 is a perfect square, we can change this to be 6i. And so really, when I look at this original problem, and I look at this, which is equivalent, I'd much more like to work with 2i and 6i than working with the square root of -4, okay? So the I is meant to create an easiness with simplifying. All right, so let's go ahead and let's now distribute. And what's going to happen is we get 3 minus 2i times 5 is going to make 10i, and 2i times -6i is going to make a positive 12, and I times I is going to make I squared. So again, it's very similar to a variable, but what's different in this case is that the I squared is equal to -1. And so we can rewrite this as 3 minus 10i, and this is going to be 12 times -1. So we've got 3 minus 10i minus 12. So now the real parts are 3 and -12, which is -9, and the imaginary part is -10i. And that's how we would write the final answer. So I is simplified, okay, but in I squared, we can replace it with a -1. All right, so let's work through one more example. Example 3. 3 plus square root of -5 squared. Okay, so first thing that we're going to recognize is that when we have a quantity squared, that we need to write that quantity twice, and we need to double distribute. You are not allowed to take the squared and distribute this. Okay, now the problem is, again, we don't want to do operations with the square root of -5 and the square root of -5. Okay, it creates misconceptions too, and it increases the chances you're going to miss the problem. So what I want you to do is I want you to simplify this, and we're going to replace square root of -5 with I square root of 5. Okay, it's not 5i. The square root of -25 would equal 5i, but the square root of -5 I would denote as I square root of 5, if you can see the difference. Okay, and the reason you want to do this is when we leave the negative under the square root, sometimes it causes misconceptions. Well, let's go through and let's double distribute and see what happens. Well, 3 times 3 is 9, and 3 times I square root of 5 is 3i square root of 5, and then we have 3i square root of 5, and then this last one is where we need to be really careful right here. Okay, we have I square root of 5 times I square root of 5. What's going to make a plus? And I times I is going to make I squared, and square root of 5 times square root of 5 is going to make 5. Okay, so if we keep going, I'm going to combine like terms right here, and 3i square root of 5 plus 3i square root of 5 gives us 6i square root of 5. But this right here, the I squared, is going to become a -1, and so this last term is just going to be a -5. Again, when you multiply a square root of -5 times a square root of -5, you're going to cancel the radical and get -5, okay? So let's continue simplifying, and we can take 9 minus 5 and get 4, and it's 6i square root of 5, okay? So What you're going to do from here is you're going to go back to the outline and you're going to work through some whiteboard problems that we did in class, okay? You'll find everything there, so get a little bit more practice with this, and I think you'll be ready for class next time.